So a slightly more complicated question this time. Our tan function has two dilations. It also has a reflection, so it's reflected in the x-axis, that's what the minus does, dilated by a factor of 2 from the x-axis, which honestly doesn't really have much of an effect on this at all. Remember that when we're talking about tan, we don't talk about an amplitude because it doesn't have one. So that too, you notice I haven't put a scale on my y-axis, it's just going to have no impact on the graph at all. And this too here is dilation by a factor of half from the y-axis, which means that it's half as wide as what it used to be. We're also sketching between negative pi and pi, so that's a little bit different as well. Now, I'm going to show you a different way of sketching these tan functions, okay? We could sort of go and do it the same way as we did last time, but a question that often comes up is, how do you know where the asymptotes are? Well, the thing is that we always know that the asymptotes occur when the angle inside the tan function is either pi on 2 or 3 pi on 2. So why don't I just go with that? I'm going to actually take that and I'm going to force the condition. So for asymptotes, okay, let the angle equal pi on 2 and so on. Okay, so the angle in this case is 2x, and I'm going to make that so it equals pi on 2, and 3 pi on 2 was the other option. So if 2x equals that, then that means x equals pi on 4, and also 3 pi on 4. So here's pi on 4 here, so I'm just going to mark that asymptote on right now. So x equals pi on 4, and the other one was 3 pi on 4, which is right here. So x equals 3 pi on 4. And continuing this pattern back, well, we can straight away see that it's going to be another one here at x equals negative pi on 4. And also another one here at x equals negative 3 pi on 4. Okay, so on top of that, I know that this is a cyclical function. We can see that the period is just going to be pi on 2 because it's, well, half the distance of pi basically. But also we could calculate the period as pi over n, so period equals pi over n, and in this case is 2, so p equals pi on 2, which is exactly what we just said it would be. And the last thing before drawing this is to know that the graph is negative, so it's turned upside down. So it will still pass through the origin, but instead of going upwards, okay, it's going to go downwards. So it's going to come down here, and it will start sort of up there, and well, we'll just have that same pattern going on. It's going to go through there, 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 and it's going to go through here, and it's going to go through here. And I'll just draw the last couple there. It's going to pass through there and go down here, and it would start up there, would go through here, and it would end up down there. So when I go to draw this, okay, remembering again that these graphs do not have a point of inflection, okay, instead it looks a little bit like that, but oh gee, this is not looking too bad at the moment. Hopefully it'll continue to be true. Notice as well when I'm drawing these, always getting closer to the asymptotes, never curving away from them. Okay, we cannot curve away from them at all. That is something which examiners will just smash you for. So that's what the graph looks like. Anyway, I'll leave that there. Pretty nice.